Welcome, everyone. Thank you so much for being here. We're so excited to kick off our harmful algal bloom training series this year. For those who don't know me, my name is Anna Holder. My pronouns are she, her, and I work at the California State Water Resource Control Board in our Office of Information Management and Analysis, or OIMA, as we call ourselves. And I am our office's Open Data Science, Equity, and Tribal Coordinator. And today I'm going to help facilitate our instructors and the discussion, and a little bit later on give some background about our Surface Water Ambient Monitoring Program, or SWAMP program, efforts and resources. But before I dive in, I just want to give a huge shout out to our Tribal Advisory Committee. They have been helping us put this training series together for, I think, maybe close to a year now. And our TAC includes folks from the Big Valley Band of Pomo Indians and UROC environmental departments, as well as folks from the San Luis Rey Indian Water Authority. And they've also kindly agreed to be speakers at some point during the training series. So we'll hear from Sarah Ryan later today from Big Valley. And to kick off our 7-course series, we're going to use the next few hours to provide just a grounding and introduction to what harmful algal blooms are, the SWAMP HAB program, and the monitoring network that includes and is often led by tribes in California. This slide shows the breakdown of the different topics we'll cover today. And I just want to point out, you'll notice we have time set aside after each part for questions and discussion. If you're like me, when a question comes up, I forget things immediately. So feel free to drop questions in the chat or discussion prompts or resources or anything you want into the chat as they come up for you. And our instructors can address them like as they're going through the content, or we can circle back during the Q&A and discussion section to talk about them. We're also going to have a break about halfway through the material. And then we'll wrap today, like I said, with a tribal highlight content delivered by one of our TAC members, Sarah Ryan from the Big Valley Band of Pomo Indians, which is going to be really great. We're probably all Zoom pros at this point, but when we are at the question discussion, feel free to raise your hand, turn on your camera, unmute yourself, whatever you want to do. I don't see anyone on the phone, but if you need to transition to the phone, to mute and unmute is *6, and to raise your hand is *9, and then to turn those off, you just do that again. As you probably noticed when you joined, we're recording this training with the intention to post it online in public spaces. We really want to post the instructions so that folks that can't make it join us today, or others that find things later can reference the material and conversation moving forward. But we really want folks to feel comfortable with having an honest discussion about these topics. So if you'd like us to pause the recording before the discussion section, feel free to just send me a chat directly, or unmute and say it out loud, and we can do that. Or at the end, if you're like, you know what, I'd rather we didn't have that discussion section public, please let me know, and we can take that out of the recording so it's not made public. Like I said, we really want folks to feel comfortable contributing to the discussion, and we're happy to pause the recording or remove some aspects of the recording before we make it public. We're happy to support that. And then again, just orienting ourselves in case some folks don't use Zoom all the time. There's buttons on the bottom of your Zoom screen to help you mute and unmute, open the chat, and I love a reaction. So if you see a reaction and you want to give an instructor a thumbs up or clap or whatever, feel free to do that as a way to engage. And if you want to, like if you're logging on, like when I join a Zoom, it says OEMA SWRCB, which is like, no one knows who that is. So feel free to rename yourself if you'd like. And you can do that with the instructions on the slide. We like to provide different ways for people to engage during this course. Some folks don't like unmuting or turning on their camera to ask questions. So we're going to use a Zoom poll today just to like get things warmed up and make sure we're all in Zoom and it works properly. So I'm going to show on the slide the poll questions next, and then I'm going to launch the poll and a box is going to pop up on your screen and you'll be able to answer the question. You might need to scroll to see all of it. Once you select your responses, you'll press submit, and then I'll share the results and we'll talk through them together so folks on the recording know what happened. So with that, here is the Zoom poll. We just wanted to see who's with us today. There's a bunch of familiar names and faces and new names and faces, and just getting kind of a check on if we've got tribal leadership, if you're part of the an environmental program, if you're a TIPO, if you're, field staff doing the FHAB monitoring or want to, or something else that is not on this list. We'd love to get a sense of where y'all coming from today, what perspectives you're sharing. We've got 75% of folks participating. I'll give it another minute or so, another couple seconds. 87%. Yeah. 93%. Great. I think the only other person that hasn't responded is probably me. So 16 of us. Awesome. Okay. I'm going to end the poll and share the results. And it looks like we've got most folks are in environmental programs, tribal environmental programs. So we've got environmental program directors or leadership. We've got some field teams, some data folks from environmental programs, and then a smattering of other folks, which is great. Awesome. And I'm going to PDF these slides and make them available so I can also add the poll results to the slides. Cool. Welcome. We're really glad you're here. Okay, let's get into it. I'm gonna pass things off to our swamp harmful algal bloom team at the statewide at the state board, Marissa and Carly. Feel free to introduce yourself, and then they'll take it away and start giving us a grounding of what cyanobacteria are and what are harmful algal blooms. I've got the slides, so just feel free to let's play the next slide game and I can advance for you. But Marissa, Carly, feel free to unmute. Take it away.
Okay, perfect. Hi, everyone. I'm excited to be here. I'm Carly Nilsson. I work alongside Anna Holder at the State Water Resources Control Board in Sacramento, and I co-manage the Freshwater and Estuarine Harmful Algal Bloom program for the water boards alongside Marissa Van Dyke. And I'll pause to let her introduce herself, but we'll be talking a bit today to you.
Hey folks, I'm Marissa Van Dyke, and we're just really grateful for the opportunity to speak to you today about these subjects in this course. Yeah, we both manage the freshwater nurturing harmful algal bloom program, which we're going to be speaking to often today, and we call this FHAB for short. And I'll let Carly take it away.
Before we do, I saw
Hmm?
Sarah come on video. Did you want to do a brief introduction for yourself too now?
Yeah,
You're welcome, Sarah.
hi, thank you. I'm Sarah Ryan, the Environmental Director over at Big Valley Band of Pomo Indians, and welcome everybody.
Yay! Gang's all here. We love it. Okay. Welcome all.
Okay, so I'm going to get us started. I'm going to sort of do a crash 101 course on cyanobacteria and harmful algal blooms. For those of you who are less familiar, for those of you who are more familiar, feel free to correct anything that I might misspeak to. Next slide. So first off, just cyanobacteria, I just want to highlight that it's been around for over 2 billion years. It's what created the first oxygen on Earth. It's naturally occurring. We couldn't live without it. And it is the base of our food web. It's part of the phytoplankton community. So it supports a lot of organisms in our aquatic environments. It's also terrestrial. You can find it even up in Alaska or further in some of our glaciers. So it is pretty prevalent all over Earth. And just to highlight, it is a bacteria. It's not an algae, although it's misnamed that quite often. Um, and under certain conditions, often with an influx of nutrients or favorable conditions, I'll go into that in a little bit on the next slide, but they can become harmful by growing quite rapidly and in large abundance. And so when that happens, we kind of change the naming convention to harmful algal blooms because they can become quite harmful. And an acronym, just to familiarize yourself with it, is we call it HABs for short, so HABs. Um, and so they've had a lot, since the cyanobacteria have had a long time to adapt on Earth. This is why we call them harmful algal blooms, because they can easily outcompete other organisms when they grow in abundance. So when they do that, they can produce toxins and or taste and odor compounds. For folks of you who may have been near a harmful algal bloom or a HAB, you may have noticed that it has a really musky smell, like dead fish or sewage. It can also have taste, have flavor to it. If you drink water that has been tainted with it, we're lucky to have most of our water treated, so that's not a problem. And then as well as they can deplete oxygen in the water column, especially as these cyanobacteria die off in that large abundance. And so when that happens, we often see these large fish die off. So just highlighting that it is an issue not just impacting the phytoplankton of the food web, but it can have impacts up the food web as well. Next slide. So I briefly mentioned drivers, but just to kind of go into that a little bit further, some of the known drivers we know are nutrients, so phosphorus and nitrogen, and that can either be from the sediments in the water, so at the bottom of a lake or river, where the nutrients are coming from the sediments and into the water column, or they can come off the landscape. So they can come from agricultural lands, sewage treatment plant discharge, and then other non-point sources. So some of the smaller contributors could be even just like fertilizers from lawns, or just erosion of nutrient-rich soils. So like if there's a big flooding event and a lot of soils being pushed into a waterway. They also thrive under warm temperatures, although I want to caveat that some have evolved where they actually can thrive in the colder temperatures. We've seen HABs be pretty prolific up in the high Sierras in some of the colder months, which is pretty surprising. But we often do see them proliferate in the heat of the summer months, right, when it's the warmest. They also need light to photosynthesize and survive. So we don't often see them in those really, really shaded river systems where they're not able to photosynthesize and there's a lot of shade in there. And why you often see them in a lot of those open areas or those back bays and things of that nature. And lastly, just highlighting that they really prefer that stagnant stratified water. So when I say stagnant, it's, in the spring, we have the big snow melt in California, often in most places. So that's moving a lot of water through. So we don't often see the HABs proliferate then, but then we see them later in the summer months when we don't have as much water. As we know, we don't get a lot of rain in the summer in California. So the water can get pretty stagnant as well as stratified. So those shallower systems where you're not having the mixing of the cold water move up to the top of the water. And so they tend to proliferate in those kind of situations. And one of the reasons why is because, especially with these cyanobacteria that regulate themselves in the water column, they have a buoyancy to them. So during the heat of the day, they move up to photosynthesize and get all the light they can. And then in the evening hours, they go back down into the water column lower to collect those nutrients. So they've evolved to be pretty resilient in terms of figuring out how to best maximize their growth. So once again, that's why, like, if there's a lot of fast moving water, it's really hard for them to regulate that buoyancy and to thrive and to actually like create bigger growth, and where we see that large upset of growths where they become harmful. Next slide. So if that's not enough information, it's also quite complex. So I just want to highlight that there's generally two types of freshwater cyanobacteria we focus on. The planktonic, which I kind of just briefly mentioned, which is the floating cyanobacteria that we see in the water column. So it's going to be those slower moving systems. We often see them in like lakes and reservoirs. But there's also cyanobacteria that grows on the bottom of a substrate. So on rocks, sticks, sandy material. And I want to highlight they're generally shallower systems because remember, they still need to photosynthesize. So they need to have that light come through the water column to be able to survive. As well as we see them in the marine environment, but those are of the diatoms and the dinoflagellates. They're not going to be that cyanobacteria. I talked in the last slide about drivers, and I just want to highlight that those drivers are really more focused on those planktonic, those free-floating blooms in the lakes and reservoirs we often see. The science on benthic growth is a little less robust at the time, but we suspect that there are quite a few of those drivers that still impact that growth. And so when the marine and the freshwater blooms can also move into the estuarine environment. So those areas can contain both. We see that a lot in like San Francisco. We sometimes see in the saltwater intrusions. So then we see some of those marine blooms come inland. We've seen them at Lake Merritt. And then as well as in the Delta, we've seen some of those cyanobacteria wash further down into the system, into that estuarine environment as well. So you can have both in the estuarine environment, both those marine blooms and then those freshwater cyanobacteria. And then next slide, please. So I'm going to kind of walk you all through different types of cyanobacteria you might come across and sort of how to train your eye on that, since we're kind of going to today focus more on the freshwater aspect of things. I'll go briefly into the marine, but I really want to focus on the freshwater today. So we're going to give you an overview of the types of aquatic organisms that form blooms and other organisms that look similar. So those can include cyanobacteria, algae, and aquatic weeds. So here on this slide, we have Phanozomenon and Oscillatoria. So those are two common cyanobacteria we find in California. I should have highlighted earlier that the focus is going to be on some of the common ones we see here in California. And these are planktonic, floating. So I say that, I caveat that, because you're going to hear me say oscillatoria later with the benthic, but those can actually be both planktonic and benthic. It depends on the length of their filaments. So these shorter filaments you're going to see more in the planktonic systems, or the free-floating. So they can have differing appearances. So with the Phanozomenon, you sometimes see them as this like chopped, like grass look. And they're pretty free floating. They're pretty obvious to see, but if you haven't seen it before, it's not as easy to know what to recognize. They can also appear in different colors from green, yellow, or brown, and they don't necessarily have to form a surface scum. I'm probably going to mention this more than once, but it's important to note that toxicity of like the toxins that are being produced by these cyanobacteria can only be measured in a laboratory. So you can't tell how toxic a bloom is just by looking at it. You really have to collect that sample, send it to a lab, and have that quantified for you. And so that's where you can learn a little bit more about the threat to humans and animals in terms of that toxin production. Next slide, please. So some other culprits we see in California is microcystis. This is really prevalent in the Delta. And this one is a little bit easier to distinguish. It generally kind of has a spilled paint look or kind of a soupy look. It's very green. It usually comes to the surface. When it dies off, it can kind of get a little bit more of a brown to a grayish tinge. But we see it pretty prevalent all over the state. And those colors, as I said, can range from green, yellow, or brown. And then the picture on the right is Delicospermum. I want to highlight that one can be somewhat of a little bit more challenging to identify in the field because that one tends to hang out a bit lower in the water column. So it's not right at the surface. So sometimes it can be, with the light reflectance, it can be a little bit more challenging to identify. So just kind of once again highlighting the importance of having the ability to collect samples and send them to a lab or have a microscope on hand so you can ID that in the field to see what you're looking at. And all of these can be differing in colors as well. And then just kind of going over a general overview of different planktonic cyanobacteria is they can have different appearances like scum, bubbling, or spit like foam. And so they really can be easily confused with that non-toxic green algae, right? Like these pictures aren't necessarily that clear that it's not actually an algae and not a cyanobacteria. We even have another culprit in California, Planktothrix, and sometimes that even shows up as like a random pinkish red. So there's lots of different colors and appearances based on optimal conditions that make it go that way. So just highlighting that there's a lot of differences and really the importance of training your eye. There's a ton of visual guides out there. I'm going to go over that in a minute, but there's a lot of resources to help kind of train what you're looking at. Next slide. Thank you. So now we're going to go into the benthic growth. And I mentioned this earlier. These are going to be the cyanobacteria that aren't necessarily exclusive to river and stream systems, but we often see them in those systems, but they're the ones that grow on the bottom of the substrate. So oftentimes rocks, sometimes they can grow on sticks and things of that nature, but you're going to see it at the bottom of the waterway. And these can also produce toxins. We've seen it a lot up in the North Coast region. So in Northern California and the Russian River North, they've been studying it quite a bit. And we see toxin production both for neurotoxins, and we've had some dog deaths even. So it is common and we do see it. And this picture is specifically of microcoleus. It's commonly found in California, and it's actually been found in other states, including Oregon and Utah. And interestingly enough, it's been most studied in New Zealand and some of their braided river systems. And even some of those are fairly pristine. So it doesn't necessarily need to be in those systems that have a lot of outside impacts to them. And it forms these thin brown mats that kind of look like a rough or smooth leather. And I know this is a terrible description, but it sort of has a texture of raw chicken skin. That was described to me, and that actually exactly explains it. And they can become easily dislodged from the bottom of the creek. It just barely takes stepping on them. Dogs can easily dislodge them with their paws. It doesn't take much. And so they quickly release and they form these larger mats, and then they start floating on the surface of the water where they can become stranded on the shoreline. And that's where we start to become concerned, right? Because when they're attached to the rocks, there's not really a lot of avenues for exposure. But once it becomes like available by swimmers swimming and coming into contact with it on the surface of the water, or those dogs and kiddos hanging out playing on the shoreline, they might have the ability to have exposure with those mats that have been released. Next slide. And then another one we see is oscillatoria. Once again, I mentioned that earlier. It can be benthic or planktonic floating. These are the larger filaments. It does have a greenish tinge to it, so it really can look very similar to that of green algae. And they can grow on rocks, fine filament on sand, or even plants and branches. And they can also be found amongst other filamentous algae, which makes it really challenging to identify. So I know I mentioned earlier, you can look under a microscope to identify what cyanobacteria you're looking at, or you can have a sample shipped to a lab. And I will go over that, Sarah, in a moment. But they can, where was I going with this? I lost my train of thought. Oh, you can send a sample to a lab for microscopic ID. And that's just really helpful because if you're still learning the different cyanobacteria, then you can start to be like, oh, I saw this. This is the sample I sent in. I took photos of it when I was in the field. And then the lab tells you what the genera you saw was. And then you can start being like, oh, training your eye to see what you see. I know a lot of our sampling folks up on the North Coast, that's pretty much how they learned what they're looking at in their system. So it's a really great way to fact check yourself on what you're seeing in the field. And then the last one I want to go over is the Anabaena. It's also really common in California, and it can actually grow in these really cool spires or bubble towers. You can see it from the photo where they're raising up. They are most common in those slow-moving and stagnant waters. And what's cool about this is like, I mean, I just think it's just a feat in simple organism engineering, but when they're releasing oxygen, they actually like build themselves up, which is what creates those fires. So it creates more surface area for them to trap nutrients to enable more growth. But as I just kind of explained it, it's not the most complex system, so it can be easily dislodged and float to the surface once again. It doesn't take much to disturb them and get to the shoreline where you can be exposed. And Sarah asked a question because we are talking about benthic. I'm just going to hit it really quick. So the lysing of benthic cyanobacteria and the dispersal of toxins as the benthic cyanos are dying off. Yeah, it's a really great comment, Sarah. So when they start dying off, the cells start lysing because they die, right? So then the toxins become available in the water column themselves. They're not trapped within those cells. So usually with benthic cyanobacteria, we're most concerned with ingestion because the toxins are trapped within those cells in those larger mats. Dogs are generally really attracted to the musky smell, so they tend to go after it. Kids, I have them myself, they tend to go after anything that's on the shoreline, especially if it looks kind of ooey and gooey. But another way of exposure is when they start doing that die off, whether it's a die off because it's the end of the season, or it can be they're getting replaced with a different genera of cyanobacteria. But when those cells lyse, then those toxins become outside of the cell and within that water column in the river. So that's another way of exposure. Next slide, please. Okay, so I talked about planktonic, the free-floating cyanobacteria, and the benthic cyanobacteria attached to the rocks, and some of the common culprits we have in California. But now I'm going to go over what is not cyanobacteria, right? Because it's helpful to know what the big X is. So this is some pictures of a red tide. So we see those usually on our coastlines and beaches. Some can form some really cool colors from bioluminescence, where folks might go out, after sunset and watch the waves roll in and see all the beautiful like colors that they have, or they can appear kind of a rusty red to a brown. And these are all formed, just kind of highlighting again, by dinoflagellates and diatoms, not cyanobacteria. They are known to cause fish and shellfish harvesting closures. Like we have an annual closure every year in California on the coastline, and they also can cause marine mammal strandings, impacting sea lions, dolphins, and even whales. And you may be familiar with this terminology, but some can cause paralytic shellfish poisoning, which is why shellfish harvesting is closed. And they cause dead zones, where there's massive areas of the ocean that are depleted of oxygen. And I just want to highlight from the recreational perspective, water contact advisories are less common for red tides, but it is known that these blooms can cause respiratory and skin irritation. We get reports all the time from surfers out in red tides that they get pretty severe rashes. So our program definitely recommends to the public that they don't get in the water, and for obvious reasons that you don't eat fish or shellfish during these times. And then green algae. I briefly mentioned that before, how the cyanobacteria can kind of nestle in with these fun friends, but they're non-toxic, but they are a nuisance because they are common in waterways. And they can range from like a fairly bright green color to dark to light green to almost a yellowish in appearance. They don't produce toxins, but they are harmful to aquatic ecosystems because they take over habitat, they clog channels, and then they also take up dissolved oxygen. They're plants, unlike cyanobacteria, which I mentioned before, they're bacteria. And they grow in longer filaments, so they can look like wet hair and stringy material. And so they don't really, they're a lot more complex than cyanobacteria, so they don't easily break apart when handled. And then when you see green algae or aquatic weeds, it's less likely, honestly, that you'll see cyanobacteria. What we often see is that this algae is actually out competing the cyanobacteria for that sunlight to photosynthesize. So if they're covering the water surface, it's really challenging for the cyanobacteria to outcompete that existing algae. They don't form roots like aquatic weeds. And then as you can see from these photos, it's really easy to mistake them for cyanobacteria. I showed you some of those earlier photos. These look very similar, which is why it's really, really important to have a lot of references and visual guides and watch a lot of training videos on how to really visually distinguish them and their textures. There are some field tests you can do, like one of which they are showing here in the far left photo. It's a stick test. So you can pick up the material with a stick. If it stays on the stick or mostly like in its natural form, it doesn't just like fall apart, then it's generally going to be a green algae. And I just want to put a plug in that we're going to go over monitoring for cyanobacteria in a future series, and we'll go into a lot more detail on that. And then another algae that I just want to quickly highlight is golden algae. Um, it's unfortunately a harmful algae that is emerging in California, and they're found mostly in warm, brackish ponds and lakes, mostly in Southern California parks. They're pretty prevalent also in Texas. If you've been there, you might have heard of them before. And they do produce toxins that are harmful to fish, as it really attacks their gills. So it can cause those massive fish kills as well. And when they are prevalent, the water appears more turbid, dark, and brownish. And it's not known to have direct impacts to mammals, including humans and birds, but obviously, if there was a golden algae bloom going on, we would not recommend swimming or eating any of the fish or shellfish in that water body. And then last but not least, of the not cyanobacteria, I just want to highlight aquatic plants. So they appear green once again, just like cyanobacteria, and they can float near the water surface. Upon close look, they'll have some leaves and stems, but I will say like a lot of these from like a far off perspective, if you're looking at it from far away, they really can look like harmful algal blooms. I've seen a lot of photos where I've actually misidentified because it was far enough away that you just really couldn't see those details. So it is really important, like when you are out in the field, to get close to these water bodies. We don't recommend handling the material without gloves, but get a good visual eye on what you're seeing. They can float, and as I said, be with green or red colors. Many have hanging roots. Some can be attached to the bottom sediment. They're a common nuisance in waterways. Some aquatic plants that we see quite often in California are duckweed and azolla. So they can have fern-like leaves or just these itty-bitty little leaves like the picture on the far right. And then lastly, just to kind of pull this all together, I went like rapid speed, but we're going to have all this presentation available to you. That was just a quick primer. But we do have, this is a printable field guide we do have for our program that we developed. It's a 2-pager. I personally have it laminated and in my field kit. It's just good to have a reference for things. And not only that, but there's a ton of other references out there. So we have another longer visual guide that's like 40 pages long on our FHAB program site that you guys can consult. There's also a ton of national resources. There's the YouTube videos. We have a lot of those links on our webpage, so reach out to us. We're happy to share any and all resources we do have, because realizing it's really hard to have a keen eye of what to look for unless you actually can see it. So just letting you know, you're not alone, and there's a lot of resources out there. We're also working on actually taking more videos and pictures so we can have a more robust library of things for the public to consult. And I did see that there's comment in the chat if we have a direct link to that ID guide. I think Marissa can throw it in the chat, but it's also a link on this PDF that we'll be sharing with folks, or this PowerPoint that we'll be sharing with folks as well.
Yeah, so before I pass it off, just great question. On these slides, if you see on the bottom, like in the green bar, some text that's like white and underlined, that means it's a link to something. So we'll get these slides to you hopefully early next week. And so you'll have all the links to all the things. And we also will pull any links that are shared like in the chat. If someone here is a practitioner is like, yeah, your guide's great, but my guide's better, and here's a public link to it, we'll make those available as well. Okay, Marissa, take it away. Why should we monitor for HABs?
Great. So we just heard from, we learned from Carly a lot of like the different needs to understand a little bit more about what's going on in your waterways, right? With all this material that can look green and similar. You've got the algae, you've got the aquatic weeds, and then you've got those harmful cyanobacteria. So why we need to monitor, it's really because these harmful algal blooms, when they occur, they're lasting for longer than just a few days, weeks, months. Sometimes they can even be all year round. So monitoring is really important to understand what's going on in your waterways, because even if you monitor at the onset, these cyanobacteria blooms in particular, they can change over time. Different genera become dominant, they have different traits, different toxicity potential. And so monitoring is really important to understand how harmful they are and what's going on, and further what their impacts are. So next slide. All right, so I'm going to go a little bit more into the impacts and also exposure routes and so forth. So what we've, Carly's been talking a little bit more about exposure, especially about those benthic blooms, why they are of a concern, especially when they detach and accumulate on the shoreline to protect our kiddos, our pets, livestock, and so forth. And so with harmful algal blooms, they have been categorized to have many different impacts, also to the environment, not just us. And these impacts are categorized by something that's called beneficial water uses. And this term beneficial water use is part of the regulatory framework of our state water policy. So framing these impacts or HABs by the uses that are impaired by harmful algal blooms is really important, so that we can integrate them into policy options so we can work towards addressing the causes of these HABs, right? Not just protection of people, but also prevention and mitigation, that kind of. So some of the impacts that they can cause is, changing the physical conditions of the water body, the way it functions. It's really impacting our ecosystems and the water and aquatic life that we all really love. And also, they're seeing, with aquatic life, they're impacting the food web. Even though they are at the base of the food web, too much of them isn't a good thing. They're causing the loss of oxygen that's necessary in the water for other organisms to thrive, particularly fish. And that's why we often see those repercussions of large fish kills of all sorts of different species, large fish, small fish. And also, for our recreation activities, these blooms degrade the aesthetics of the water body, right? It's going to look bad, it's going to smell bad. Also, water, as it needs to be treated for drinking water. Those water treatment plants have to have that technology and spend more time treating it to remove the taste and odor compounds that these things can produce, and then also control any harmful toxins that they produce as well. So altogether, these impacts really can degrade a variety of beneficial uses, including drinking water, tribal uses, cultural uses, subsistence fishing, aquatic life, like we mentioned. Next slide. All right. So we've heard a little bit more about exposures. I'm just going to dive into this in a little bit more detail. The primary routes of exposures, there's 3 of them off the top of this chart. And that's through skin contact, ingestion, and inhalation. So all cyanobacteria have these dermal irritants in them, so they can cause irritation of the skin, your ear, nose, and throat by varying degrees, right? Those mucous membranes is what specifically, I think some physicians will speak to. And when you swallow these cyanobacteria cells, they can also cause gastrointestinal distress because of those irritants. So again, that's like from skin contact. Then ingestion, it's more common, the most common perhaps, and that's often through drinking untreated water from waterways. Those waterways can have smaller microscopic particles, so these cyanobacteria cells that you just didn't see. There's also cases of intentionally ingesting these HAB materials, right? The mats, these cells. This is again, something that Carly said, that dogs actually are drawn to the smell of these cyanobacteria, and those mats, even livestock are drawn to the mats and their smell as well. And then during water recreation, we're most concerned with the accidental ingestion, particularly by children. And so that's something that we have a lot of messaging and advisories to help prevent that kind of exposure. And then through inhalation, this is another type of exposure. We often hear about this from red tides as well. The irritation just from living or playing nearby these red tides. But also this is a concern with cyanobacteria, and it's still under research to really better understand the human health risks from inhalation, and for those folks that do live nearby. So that's something that we can expand on later. And for the impacts from these exposures, it really kind of depends on the type of cyanobacteria and their toxins that you're exposed to. That's why there's such a broad range, shown here in this infographic. So some symptoms include gastrointestinal distress. It can be severe to like organ damage of the liver and kidney, and depending on the cyanotoxin. It can cause respiratory illness, neurological issues, again, from those neurotoxins, and also some cases do lead to death. Anatoxin A is one of the types of cyanotoxins we do detect in California, and it's called a very fast death factor. This belongs to a category of toxins with this concerning characteristic, right? It's very fast acting kind of toxin. And we have historical evidence of this impacting dogs, particularly in the northern part of the state. So, altogether, in summary, this isn't just a water quality concern, not just for water quality monitoring, but it's also a health concern for everyone here in our state. And I'll pass back to Anna. Thank you.
Thanks, Vanessa. Yeah, so before we dive into details about the HAB monitoring and response history in California, Marissa mentioned tribal uses and the regulatory framework at the Water Board of Beneficial Uses. And if that's new terminology, we just, again, wanted to provide some grounding and information that can inform the Water Board's tribal beneficial uses process and how HAB monitoring can be part of that. So if you're here, you already know that Indigenous peoples have relied on water to sustain their cultural, spiritual, ceremonial, and traditional lifeways since time immemorial. And these unique practices and lifeways can be very different from recreation, like we've talked about previously, and have not always been protected through state and federal water quality statutes. And in some cases, we're not really accounted for when those statutes were enacted. I love this graphic when it comes to HABs. It was created by the Big Valley Band of Pomo Indians, the Karuk tribe, with assistance of Mio Marufio and Dr. Pfeiffer several years ago. And it's a great illustration of those potential ways tribal folks can be impacted by HABs while doing their cultural practices. And as noted on the slide, an individual's use of water and exposure can be, repetitive, gender assigned, and long-term, and may even occur, secondhand through the use and trade of plants and animals that have been in contact with HABs, which is, very different from like you're just going to the lake for the weekend or something like that. It's just a very different experience and can have very different health impacts for Indigenous peoples in California. Tribal beneficial uses are an important step in California's efforts to recognize and protect those tribal practices, lifeways, and uses of water under state and federal statutes. So for many years, California Native American tribes advocated to the water boards that existing beneficial uses, drinking water, recreation, that sort of thing, did not adequately reflect how tribes use water. In 2014, California tribes initiated a collaboration with the State Water Board, and together over the 4 years created the definitions that you see on the slide, known as tribal beneficial uses. In 2017, the State Water Board adopted a resolution which added these to Part 2 of the Water Quality Control Plan for inland surface waters, enclosed bays, and estuaries of California. And that plan is often referred to as the SWEBE. So if you've heard that, that's what this is referring to. And that's where in our regulatory framework, that's where these tribal beneficial uses are defined. And so we have tribal tradition and culture, which is uses of water that support the cultural, spiritual, ceremonial, or traditional rights or lifeways of California Native American tribes, including but not limited to navigation, ceremonies, fishing, gathering, or consumption of natural aquatic resources, including fish and shellfish, vegetation, and materials. So that's tribal tradition and culture can encapsulate a lot of practices. Tribal subsistence fishing, or TSUB, is defined as the use of water involving the non-ceremonial catching or gathering of natural aquatic resources, including fish and shellfish, for consumption by individuals, households, or communities of California Native American tribes to meet the needs for sustenance. So that one's just focused on consuming aquatic resources for sustenance. Having consistent definitions statewide was an important first step in protecting tribal uses of water, but in order for them to impact the protection and restoration of water quality throughout the state, they need to be designated and implemented throughout water boards' processes. And the table on the slide outlines the major components of the tribal beneficial uses, or TBU, designation process. Each regional water board and some divisions in the State Water Board may approach these steps differently, and the approach will depend on input from tribes, staff capacity, regional water board priorities, and available resources. And in some cases, these steps may occur in like a different order, depending on the needs of the region and participating tribes. But big picture, most regions and the state water boards are focusing on one or more of the first 4 steps on this slide. So we're in the early phases. And as we saw on the previous slide, full implementation of a tribal beneficial use will take many steps, but once they're implemented, they can really help the water boards, so the state board and the regional water boards, assess whether water is safe for tribes to continue their cultural or subsistence practices without putting their health at risk. And so more specifically, the tribal beneficial use water quality designations help the water boards ensure that these uses are considered and safeguarded in water quality policies, planning, permitting, enforcement, and other regulatory processes. Part of the designation process requires the collection of information, particularly from tribes. So tribes are being asked to provide the information on the slide. This information is requested to help us understand those exposure pathways as they relate to specific water bodies, so that we can protect those uses effectively. But I just want to note that I'm coming from the state board perspective, and I want to flag that providing that requested information on the previous slide may not be straightforward for tribes. We know it's not for many because we've been in conversation about this for many years for a multitude of reasons. So if your tribe is interested in opting into the tribe beneficial uses process, I really recommend checking out this tribally led presentation from a 2024 the US EPA Tribal Conference. It was led by tribal practitioners and experts that have been in the TBU space and advocating for tribes for a really long time. And they do a great job of going over the TBU process from their perspective and things that tribes might want to consider as they engage with the water boards, like what type of information to share and how to protect information that's sacred that you don't want to share with the state. Okay, so with all of that in mind, I'm going to pass things back to Marissa, who is going to tell us a little bit more about recent-ish history of harmful algal bloom monitoring and response in California. Take it away.
Yeah, thanks. All right, so I'm going to give a brief history. This timeline does cover about 50 years, so it's quite a length of time. Just helps us frame a little bit and understand the course of addressing HABs across the state, the progress we've made, and like also the challenges that we've all encountered. So harmful algal blooms became recognized in the state starting in the 1970s in Clear Lake. Some research that was ongoing there, some recurring blooms, and again, Clear Lake is located in Lake County, just to get us oriented. But although HABs have been documented since the 70s, there hasn't been any dedicated program to address harmful algal blooms across our state until an assembly bill was passed in 2019. And that dedicated 6 staff and less than $1 million towards addressing the assembly bill's mandates. And of those 6 staff, you've got 2 here today with you, to give you that understanding who they all are. And we'll provide a little bit more information in our next training series and also introduce you to those staff. Notably, the state hasn't adopted any regulatory measures or have specifically to protect about solve on the cyanotoxins, and also to address the drivers of harmful algal blooms. So some of the drivers of algae proliferations, particularly nutrients, has been addressed in some historic regulatory measures, even in Clear Lake, but those were not designed to address cyanotoxins and cyanobacteria specifically. But I just want to give you kind of like that framing. And so more recently, so since the 2000s, tribes have been really active in elevating HAB issues, particularly by coordinating community networks. And particularly those networks are still active today, like the CCHAB network. They've also promoted standardizing guidance for responding to HAB events that we'll go over as well. And they've also supported legislation to dedicate funding and staff to these issues. We really appreciate tribes' efforts. We want to recognize their contributions to the HABs field in our state. Next slide. Right, so in that timeline, we saw something about standardized guidance that happened in 2016. That's now actually it's reached a milestone 10 years ago. And that guidance standardized the processes for responding to HAB events in recreational waters, particularly the cyanobacteria HAB events. And when this was published, this was adopted by this community network under the Water Council in California. And it's something that the water boards has been implementing through the FHAB program. And this opened up an avenue for us to begin collecting data, particularly HAB incidents that are reported to the state. So we're presenting some of this data here today with you. Here on the right, there's a graphic, and that's showing us the data that's been reported to us through our water board's online HAB reporting form. This form is open to the public. We get many reports from them. We also get reports from partner agencies and also from tribes to make us aware of what they're seeing from their monitoring as well. And responding to these HAB events is really important. It's a measure that one of our primary measures in the Assembly bill that funds the water board's FHAB program, and we dedicate majority of our resources to that response to protect public health. And while incident response is critical to address these HAB events and also address those complaints that come in, particularly about illnesses, the monitoring done in response to these reports is reactive. You might have missed the peak of the HAB event. It's one of the constraints of having a reactive monitoring. And while it does inform the public health advisory that's necessary at that time of monitoring, that data is not sufficient to really measure the status and trends over time of that bloom. So rather proactive, comprehensive monitoring data is really necessary to answer those status and trends. But with this data that we have analyzed it and made some really useful information from that. And again, from these illness complaints, from bloom reports, and that water monitoring that's done in response to it. And by looking at that, it's really showing that this is a statewide problem. It's not isolated to individual regions around the state or just certain watersheds. And we're also seeing that illness complaints are impacting so many different types of populations as well. Our animals, our livestock, and also ourselves and our families. And we're finding that these HAB events are occurring for longer periods than previously thought. I mean, it used to be considered something that just blooms for a few days, maybe a week. And that's definitely not the scenario that we're seeing around California. And we're also seeing that these blooms are occurring outside of the summer season. So that need to really expand the monitoring to cover the full recreation season, even like longer, as long as the waterways are still being used where you can get potentially exposed. So recognizing the need for comprehensive proactive monitoring, the California did develop a statewide monitoring strategy. This was developed with many different technical advisors to really promote different strategies to get this data, particularly by integrating the development of partnerships and also promoting use of other data, other external data, not just data that's produced from the water boards. The strategy was published 3 years ago with this really large vision for this comprehensive monitoring, and until it's funded and the funding is dedicated to it, we're going to continue evaluating the data that's readily available from this incident reports tracking. Next slide. Okay, so as mentioned before, we're tracking not just the reports of HAB incidents, but also we're tracking illnesses. So illness complaints can just be like suspected illness, or also one that's confirmed to be HAB related. That's what we're investigating and tracking. And again, these complaints are voluntarily reported to the state, so it doesn't necessarily include all of these cases, but the ones that we're aware of. And based off these illness complaints that we received since 2018, we're seeing that HABs are not isolated to just certain counties. So looking here on this map, on the right, we do see that there's a gap here in the northeastern counties, but there isn't actually any data coming from them. We suspect that's due to it being more a rural area without a water board's office in close proximity, and also less outreach reporting to us. Just wanted to clarify that. Otherwise, the map here shows you like the different types of illnesses that we've been able to confirm in those counties, impacting both humans and animals. And then the graph on the left, there are some peaks here we wanted to highlight of illnesses that are reported to us. We're seeing peaks during the summer months, but we do receive reports of suspected illnesses year-round. And we're tracking these impacts to humans, domestic animals, so our dogs and livestock, and a lot impacting fish and wildlife as well. And we're finding that these peaks of illness cases are occurring near summer holidays. And there's a significant increase of people and their families recreating in waterways around these major summer holidays. So when monitoring is done proactively, before these holidays, it can inform potential recreational advisories to help protect the public and inform them of those potential hazards, inform them like where to go instead. And also we're finding that we're having some proactive monitoring helps us inform these illness investigations as well to determine if they are HAB related. And by knowing this from reviewing this data that we have available, the Water Board's FHAB program has been hosting a pre-summer holiday monitoring and assessment program for a number of years. It started in 2018, corresponding just by coincidence along with these illness reports as well that began to be tracking. And we collaborate with many different community networks to proactively monitor in the 2 weeks prior to major summer holidays. So there's 3 major summer holidays that we target: the Memorial Day, the 4th of July, Labor Day weekends to get that data. And this is something that we can continue trying to support as best as we can with our resources and expanding this monitoring at popular beaches and other waterways. And this is one of our good examples of some proactive HAB monitoring across the state. Some other proactive monitoring is also occurring in some individual lakes as well. And we also taken that data to inform any recommended health advisors as well. And we'll go over illnesses and also monitoring design and monitoring options in future training series opportunities. And so this is just a brief overview. All right, next slide.
Awesome. That was a lot
Yeah.
to take in. Thank you so much for that. We've had some Q&A along the way, but before we go into a 15-minute break, do folks have questions about anything, anything you want to discuss? And again, if you want us to pause the recording before you unmute and ask your question, please let us know. Oh, yeah, Sarah, go for it, please.
I just wanted to thank Carly and Marissa and you, Anna, for that was for your presentations. It was really thorough, and I know that it was probably a lot, but just great. The level of detail I think was fantastic because it really is all of those things that you were talking about are the things you need to think about with a program. And the fact that that the state is, has a really capable staff who are working on these things on a regular basis. It's just really great that that you guys are out there, and I feel like you're really good partners in this. So just want to thank you for that level of detail and just the depth and the breadth of your program. Thank you.
Thanks, Sarah. You're just the best. We love partnering with you too. And yeah, that was a lot of detail, but as we mentioned a couple of times, or as Carly and Marissa mentioned, we're going to get into more detail in future courses. So if something piqued your interest about monitoring or response, like the illness stuff, we're going to dive even deeper in future courses. And those, just like this one, will be recorded and we'll share slides and things like that. And we can go over the courses coming up before we close today. Any other questions? You can go back to slides. Okay. Feel free, if a question comes up for you during the break, feel free to add it to the chat and we can either try and answer it when we come back or answer it through the chat. But we want to make sure you get all the information you want to receive today. That keeps us right on time. So let's come back in 15 minutes and so at 2:50, 16 minutes, and we'll dive into all of the HAB networks that we've kind of been alluding to this morning or this afternoon. Okay, I'm going to pause the recording. We'll see you in 15 minutes. Dive back in. Welcome back, folks. Again, that was a lot to take in. I hope you were able to maybe take a step outside, refill your beverage. I got a new cup of tea. We are halfway through, and the next half is just going to be great. Hang on to your hats. Okay, so I'm going to go through an introduction of the monitoring networks and program networks, and then we're going to pass it to Sarah. You'll notice we've got a lot of time for questions and discussion before we close today. So please think about questions. Sarah's going to deliver a fantastic presentation, and happy to chat about things that you want to talk about. So let's talk about networks. You've heard from Carly, Marissa, and I at the statewide surface water ambient monitoring program, and we've talked a little bit about the CCHAB network. So that is the California Cyanobacteria and Harmful Algal Bloom Network. And this is a network of the California Water Quality Monitoring Council, and is a community-driven network that was established in 2010 and really has been led by tribes from the beginning. And the goal is to create and promote statewide monitoring to figure out like where our hotspots are, how we can work together. It includes tribes, state agencies like ourselves, non-governmental organizations. There are 4 meetings every year, and they have subcommittees that work on key issues that come up in the network, related to research, sharing information, developing those products, so that statewide standardized practice that we talked about before, that was developed through this group. And there's links at the bottom of this slide to their webpage. We've got their 2026 meetings. They just had a meeting a couple weeks ago. I don't, what is time? January 14th, however long ago that was. They're usually pretty good about, getting notes and agendas and things on their webpage if you want to check out what was discussed. And the next meeting is in April. And they have an email list. So if you're curious about this and you want to stay informed of what's happening, you can find a link to that on their webpage. Okay, I've mentioned that Marissa, Carly, and I are from the State Water Board. I started with the water boards as a Sea Grant Fellow in 2019. And when I started, the water boards is a confusing place. So in grounding presentations like this, I like to just kind of give an overview of like what the California water boards are. So it's actually 10 different agencies. So we've got the state board based in Sacramento, indicated by the black star on the map. And then there are 9 regional water boards. Those are the different colors on the map as well. And the mission is really to preserve, enhance, and restore the quality of California's water resources, among other things, for the benefit of present and future generations. There's a lot that goes into the mission, the protection of the environment, public health, beneficial uses, all of things that we've talked about today already. At the State Water Board, I just kind of wanted to give you a sneak peek into our org chart so you can kind of get a sense of where we are at the State Board. So we are in the Office of Information Management and Analysis. That's kind of where Carly, Marissa, and I are in the org chart for the Surface Water Ambient Monitoring Program. If you've engaged with our Tribal Affairs office, you're participating in the tribe beneficial uses process, you have requested consultation, you've probably engaged with our tribal liaison, Adriana Renteria, who's in the Office of Public Engagement, Equity, and Tribal Affairs. So just OPEDA, OEMA, we're friends at the State Board, different offices, but here to support tribes. The Office of Information Management and Analysis feels like word salad every time I say it. So I just want to kind of do an overview of like what our scope is in OEMA. We have, we do a lot with environmental monitoring, so surface water ambient monitoring programs. So we collect data with our FHAB program. We've got a couple of other programs that I'll talk about in a second. We also have a data management and quality assurance arm. And we help the water boards make our data open and accessible to the state. It's public data, right? My job in OEMA is to help to facilitate relationship building, partnerships, and engagement with our tribal government partners throughout the state. But we also are trying to do more with community-based organizations and non-governmental organizations with our work. And we are always looking for new partners. Our scope is pretty broad. We're non-regulatory, so we have a lot of flexibility in what we can do and how we can partner. If you're interested in water and or data, let's chat. We could probably find a partnership if that's something of interest to you, or support your work in ways that we can. Diving into our swamp program, that was created through legislation back in 2000. And the legislature basically told us to lead and facilitate collaboration and coordination of surface water monitoring between the water boards and all of our partners, some of which are on this slide, but there are many more that are not. Their logos are not on this slide. But we can add yours if you want. Like I said, I didn't mean this for this to be a sales pitch, but here we go. Anyway, so we've talked about the FHAB program today. That's the program in the middle surrounded by that orange box, but I just wanted to flag for you. We also have a bioaccumulation program. So that program is really about understanding, concentration of pollutants like mercury and PCBs and fish tissue. And we've got some really cool efforts going on to help with the science communication part of that public health piece. We have our bioassessment program, which is responsible for understanding the health of rivers and streams throughout our state by looking at bugs and algae, among other things. We have our toxicology and contaminants program that looks at sediment at the bottom of watersheds to understand, what's happening in that space. The spoiler there is there's pollution and pesticides in lots of places, and we've got a lot of work to do to get things back on track. Those are the 4 statewide monitoring programs, but then there are also region-specific monitoring programs that are led by the regional boards. And so there are 9 regional monitoring programs. And the title in each of these boxes is a link, so you can get to a link to those respective programs. We talked about tribal beneficial uses earlier, and I just like to use this graphic to think about how swamp and our data can help protect and restore water quality in California. Like I said, we don't have any regulatory authority, but the data that we collect or generate amongst ourselves or with our partners can feed into water quality assessments through the California Integrated Report that is based on at the state board. And that report develops our 303D list of impaired water bodies, which then kind of is shared with the regional boards, and that informs the development of TMDLs, restoration, beneficial uses, things like that. And so each piece of the water board has, as we know, a different scope, a different regulatory lens. And so SWAMP can really be the foundation and work together to support the rest of those pieces. Outside of the water boards and with our partners, our data and our efforts also involve, harmful algal bloom guidance that we'll talk more about later. And we have fish advisories, for example. Again, a lot there. There's a lot of moving parts, but just note that, the data that we collect can inform the rest of the water board's process. Okay, Marissa talked a little bit about this already, but our harmful algal bloom was, again, created through legislation back in 2019 and does a lot to coordinate immediate and long-term event response. That's like the bulk of our work. We do monitoring and assessment when we can, And we do a lot of outreach and education and communication about HABs and public health in a multitude of ways wherever we can. And there's a link to the webpage at the bottom of the, what's that thing called? The slide. And yeah, as we heard earlier today, harmful algal blooms really have connection to public health, environmental health, tribal health, drinking water. And so this program can really help inform our decisions on all of those topics. I think Marissa also mentioned that legislation funded some staff to do this work throughout the state. So those folks are highlighted in green on this slide. There's about one staff person focused that has harmful algal blooms in their workload per region. They help with coordinating, harmful algal bloom response, monitoring, and communication. And I'll just note that in a future course, we've invited these folks to join us. So they'll be able to say hi and match names to faces and things like that. The incident response process takes a lot of steps that are outlined on this slide. So you saw graphics earlier of like those incident reports that anyone can submit. There's a link to the web report form on this slide. We get that report and then work with our partners to assess what's going on with that incident. We might need to follow up with the reporting party to get more information. We might send staff out to collect samples, as Carly mentioned. A photo doesn't always tell you if something is harmful or not. We might lead monitoring or work with our tribal and non-tribal partners to collect the monitoring to assess what's going on with that harmful algal bloom, post signage, and then continue that work until the HAB goes away or we can make sure it's safe for folks to use that water body. There's also, if an illness occurs, there's a separate process to follow up on illness reports. And I am not the expert on this. This is super high level, and Carly, Marissa, and our illness work group partners are going to take a deeper dive into all of these steps again in a future training. I think the next one. Marissa also mentioned our FHAB monitoring strategy, and that prioritized 5 beneficial uses related to harmful algal bloom monitoring, one of which was tribal tradition and culture. That graphic that we saw earlier makes it really clear that there's a strong link between harmful algal blooms and tribal tradition and culture and practice. We're prioritizing freshwater systems mostly in the strategy, but the estuarine land sea interface is also really important. And we've got 3 approaches. So we'll talk a little bit about our state-led monitoring and response and surveys, but partner monitoring, partner-led monitoring is critical. As we've seen in the history of HABs, tribes have been strong leaders in this space for a long time, and that partnership is invaluable. And so we're hoping through this training series, we can continue to build that partnership so we can all work together to protect and restore water quality and public health in California. We have, to that end, we have an official partner monitoring program. So we send out solicitation for participation in this in the spring each year. So it should be sent out through that CCHAB network email list in March or so. And this program, basically, we try and coordinate monitoring with partners, and many of which are tribes. And depending on what the needs are and the resources that we have, we might be able to provide funding for lab analysis. So someone might collect a sample during a HAB, and then we would pay for the analysis. You might be able to send kits and other resources. Totally depends. And we encourage folks to reach out to us. And if you're interested in exploring what this might look like for your program, your tribe, and let's chat about what your needs are and how we can and help and support your work. There's a link to the webpage with much more information about this partner monitoring program, as well as a flyer, because I'm looking at my big monitor and I can't read the text on the flyer on the slide. So if you want to really zoom in there and take a peek, there's a link to that as well. That's a big picture on the networks, but before I pass it over to Sarah, just wanting to see, I mean, you're part of the CCHAB network and others here might be. So if you have any thoughts to fill in gaps that I may have missed, we'll talk about the CCHAB network in more detail next time, I think, as well. Any questions folks have about what I went over really briefly before we pass it off to Sarah? Great. If a question comes up, I'll be checking out the chat, so feel free to add it there. All right, Sarah, come on down. You should be able, I'll stop sharing. You should be able to share your screen if you want to and run through your slides.
Absolutely. Let me go ahead and pull that up. Oops. Okay, I'm going to share my screen.
It's crazy. We share our screens all the time, and every time it's like I question my IQ. It's always a thing.
It's a thing. Always, always. Okay, I'm hoping it will.
Yeah, that looks great. It's perfect.
Okay. Hey everybody. I really excited to share some information about Big Valley's program. Fortunately, there's not a ton of overlap because the previous speakers went into some excellent detail about what's happening at the state and also some just really good information about, you know, even how to start observing cyanobacteria blooms. Fortunately, my presentation is how we're using this program, a little bit about how we started it, what were our concerns, and then also how we're using the program when it comes to the things that we're concerned about with cyanobacteria. So here's overview that I'll go into our program, some impacts to beneficial uses on Clear Lake that was talked about earlier. It's basically the core of any of the Clean Water Act, and our water monitoring programs, you know, funded by EPA is all about, you know, what are the uses of water in that area and what are the things that are potentially impacting that water. And so you develop your monitoring programs around the potential impacts that could be to the uses that are happening in those areas. So it's really, you know, useful to see, like, is this a water body that's, you know, it's a drinking water reservoir, or it has drinking water coming from it, or is it just where people go fishing, or are there tribal cultural uses in it? You know, and it could be all of the above, but it's really important in your water monitoring program to identify that. So then we will go into some of the different uses that we're thinking about with Big Valley and Clear Lake and the tributaries to Clear Lake, and just how cyanotoxins and cyanobacteria, how we're monitoring them and how they're potentially impacting those uses. So as was stated earlier, there are water quality impacts whenever you see cyanobacteria blooms. Here's a bloom that looks like pea soup. And this was in the early stages of the blooms on Clear Lake really started in earnest around 2009. And even though, as Carly said, they're millions of years old, there's a lot of water bodies in around the world that have them. I've lived in the county since 2001, and of course, many people have, of course, the tribes have been in the area and on this land since time immemorial. Um, the programs that we've had to look at water quality really did not note anything until the early 2000s. So this and this is the type of thing that you see, and it can smell like raw sewage, or it can look like teal paint was spilled on it. No matter what, when it dies off, it can drop the oxygen levels in the water, and that can lead to fish kills. If you're getting drinking water from this, even if it's going through a public water system, they have to filter this stuff out because this is, many, 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 many colonies of microcystis and several other types of cyanobacteria that are in here in this picture. So there's a lot of cost and also just the concern and the fear about the water safety. So these are all things that were happening on Clear Lake, which is the largest natural freshwater lake in California, has over 100 miles of shoreline. Um, and so this really started happening on Clear Lake around 2009, looking like that, and then happening every single year. I mentioned the cyanobacteria blooms that look and smell like raw sewage. Here it is right here. Old name is Lingbia. Can't remember the new name at the moment. Those things change a lot. We also look at the water samples under the microscopes. This is one of our photos. This is Dolichospermum. And I want to point out that in the case of the monitoring on Clear Lake, this was a program that was started by Elam Indian Colony and the Big Valley Band of Pomo Indians. I was the environmental director at Big Valley at the time, still am, and the environmental director, Corolla Kennedy, over at Elam. We were the two shoreline tribes that said, this is concerning. We need to get more information about the safety of the water and just try to figure out what the heck's going on. So that's the program started in 2014, and we've been doing it ever since. Elam is no longer doing the water monitoring on Clear Lake, so we took over their sites. We didn't get any extra funding for it, but we added their sites into it and have been doing the whole lake and all of our monitoring locations since about 2020 on our own. This slide was already shared, this graphic that we created. We were asked to create a graphic that explained pollution and more particularly cyanotoxins and how it could the routes of exposure, the potential impacts for tribes. And so as was stated, we worked and got some feedback from various folks, including the Karuk tribe and others, Mio Marufo, who really said, make this into a circular thing and try to show, that icons, which I thought was a great idea. So when there's tribal traditional uses going on, there are a number of things that could be happening that could lead to cyanotoxins and even cyanobacteria getting on your skin or inhaling it or ingesting it or coming in through food of various types. And so that's why we felt it was really important for the state to recognize that, it's complex, it looks different for each tribe, and it needs to be fully included when tracking and counting the exposure of toxins. So here, next few slides, a little bit about our program and how we've developed it. Like I said, in 2014 is when we started. So immediately after seeing these incredibly high toxin levels in the lake, we started a Clear Lake Cyanobacteria task force. And it's no longer meeting quarterly. There's like a lot of things that have grown since then. We were using these little strips that can tell you if there's up to 10 parts per billion of microcystin or antitoxin in the water. And so we were using some of those. and we were mainly testing for microcystin. We expanded in 2015 to additional sites. We also started doing microscopy and looking under the microscope for, which cyanobacteria it was, and sent off for analysis of the main four toxins that cyanobacteria can produce, which is microcystin, anatoxin A, cylindrospermopsin, and saxitoxin. In 2016, in partnering with Elam Indian Colony, they were started to monitor toxins in the drinking water systems because 65% of the county gets their drinking water from Clear Lake through public water systems, but there's also a number of people who get it from their own pipes into Clear Lake. So we started working with the public water systems and looking at toxins in the finished treated water that they were sending to all their customers. We also added these field measurements of chlorophyll A and phycocyanin because there's a TMDL, which is part of the Clean Water Act, about how you're going to clean it up so that the uses are no longer impaired. And so we wanted to look at what these are both pigments produced by cyanobacteria, and then microcystin analysis. And then we started to do some creek sampling. We were looking at some genetic testing. Fish and shellfish the following year, started looking at toxins in the fish and shellfish. 2019 is we developed that graphics that you just saw. 2020, a signage tracker where there are now signs that are established at all of our sampling locations and in other locations that has a QR code that links back to Big Valley's data. And this was something that the county agreed to put on those signs. We started to analyze in 2021 the self-supplied drinking water systems with a CDC grant with Tracking California, a nonprofit, worked with the public health officer to alert for cyanotoxins in the drinking water, started to do additional analysis in the creeks using spat bags, which is basically picking up all the accumulation of toxins that are coming through with the water flowing, because that's the benthic cyanobacteria program that Carly spoke about earlier, and also started to collect samples to look at cyanotoxins in other water in other foods of the tribe, like tules and mud hens. We're now partnering with somebody from UC Davis for a microcystin biomarker study, which is looking at, what your liver gets damaged, but it's don't want to really do a biopsy on it. That's pretty, or during an autopsy with animals, it's nice, like if there could be markers in urine or blood that shows that there's some damage because of microcystin. It's a lot less invasive, so we're working with them on that, and how traditional foods are potentially impacted, and this is a source. So we have a lot of sampling that we did for that. So that's how our program is tribal centric and tribal led, and so we can go out and monitor when we want to and where. And so we will go out and sample before big dances because people go in the lake afterwards. And so it's good, and we have various sources of funding, which I'll get into in a second. We've also done trainings with tribes. We've developed this thing, kickstarting a tribal monitoring program or cyanotoxin monitoring program. Started in 2022. We got some funding from BIA and also the Bay Area Council. And then you can see it's a 107-page document. We change it up periodically. Haven't done any training in the last year or so, just not enough time. But you can see all the different things that we cover in the training. And I'm so glad, and this is why we were so happy that the FHAB program wanted to do something, based on what the state was working on with cyanotoxin monitoring. And that's why we're talking a lot, because, Big Valley had already done a number, several workshops that went into all these details, like field equipment and kits and choosing labs and all that sort of stuff. So that's something that we've done with our program. So in looking at cyanotoxins impacts, and I'm going to hit all these things pretty briefly. So, however, that's really what started it all. So looking at human exposure first, because we knew that our members were using the water in all sorts of different ways that weren't necessarily, practiced or understood or anything or measured or monitored in any sort of way by the state and maybe even by health officials. And so that's why we wanted to see what the toxin levels were. So when there, and I'll show some information on this, when there are levels of cyanotoxins, like right here, this slide is showing a total microcystin of these 4 congeners. Don't really have time to go into it. It's just like the main 4 types of microcystin. This was some analysis that a lab early lab we were using. We don't use them anymore, but they measure in total microcystins in these congeners. You could see that even with just those 4 types of microcystis, sorry, microcystin, that's it. That it was over 2,000 parts per billion or micrograms per liter, and that's well over the danger. The danger is 20 micrograms per liter. So people should be staying out of that water. Don't eat any fish or shellfish from those areas. I think this is even an older sign. Don't even go boating in it because the aeration, the aerosolization of the cyanotoxins are potential route of exposure. So, living right on the lake as the tribe does and using it in so many different ways, it's just a big part of staying involved and wanting to know more. Some of our monitoring, because we're out there every other week throughout the summertime and then sampling, and then once a month in the winter months, like right now. But we take pictures when we're out there. We want to see these site conditions, and you could see that cyanobacteria, depending on which genus of cyanobacteria or genera, multiple genus are out there, then it's going to have a certain look. And so here's the white that's in this picture, all dead fish. And here's an example of Microcystis and Lingbia. Like I said, it has a new name now, can't remember. And so that's like a mixing of both of those kind of look like this. This is what it looked like under the microscope. So here's the Lingbia with its sheaths, and here's a Microcystis, which is a colony of cyanobacteria as opposed to a filament. So, looking at under the microscope is really interesting. It doesn't take that much training to do it, because you're only going to have so many, in your water samples. Moving into drinking water, the icons that you see along Clear Lake are where the public drinking water systems are that serve through 17 public water systems, serves about 60%, 65% of the county. The US EPA developed a safe drinking water guideline on the levels of microcystin that's acceptable, or anything above there would be potential health impacts. And I believe they set it at 0.3 micrograms per liter in drinking water over a certain amount of time, I think a 10-day period. And so that's the lower level, that's like the children level, kind of children's safety level. So there is some, a threshold at which to be measuring against, when you're looking at toxin levels. And so but because cyanotoxins are not part of the Safe Drinking Water Act yet, they're not standards, the drinking water systems don't have to test for them. So that's why when we started encouraging them to test, because people were concerned, they started to respond, and they did test, and they did pay the money to send off to a lab or to send to ELEM's lab to look at toxin levels. So that was because, the people were asking. So encourage your drinking water systems to test and see if you have any issues. We never have, I've seen all the data, and no public water system got above 0.2 micrograms per liter. So 0.3 is where the threshold kind of starts. So there are toxins in treated drinking water. I've seen it, it's in the data, but it's below the threshold level. We also look at fish consumption. I'll go into this one a little bit more. You're seeing our spreadsheet here, which is showing the toxin levels in the tissue of the fish. This is from a study that we did with a Cal EPA EJ grant. And here with the stars, I'm marking where the microcystin toxin level is above the threshold that OEHA, the Office of Environmental Health Hazard Assessment, has recommended it should be below 10 nanograms per gram, and that's for safety of eating one fish meal a week. It's not subsistence level. So, it's just what we're doing with the data. Also, noting that the county used to put signs out saying if you don't see a bloom, it's fine. And we were noting that, like in this picture, you can have evidence of bloom, green tinted, but the toxin levels were 0.67 micrograms per liter, which is below the caution threshold. But in this picture, where you can see the sampler's boot right here, it was almost at warning. It was 5.6 micrograms per liter. So the toxins can be present with no obvious bloom. Widespread blooms don't always have elevated toxin levels. And so we're able to determine that with our regular sampling. We're able to get the county to change their signs so that it didn't say no bloom, no problem, basically. In our development of our program, of course, we're looking at what the standards are and just looking at the reference materials. So this is a great chart that is on the mywaterquality.ca.gov/HABs site. I know Carly, or not Carly, Marissa, I remember talking about this with you years ago. So happy that this chart is up here because you can see if you're doing microscopy and you see Anabina, well, you know that it's a microcystin, Cylindrospermopsin, and saxitoxin producer. So we use this chart a lot. We keep it right next to our microscope, actually, and we look to see, oh, we're seeing, Seneca cystis. Oh, that's just a microcystin producer. We don't need to send off and analyze for any other toxin. Also, these guidelines of, whether it is acute water intake for cattle, so if you've got cattle going in and drinking the water, they're getting access to it, or a dog, all of these levels have been suggested for microcystin and two of the other toxins that are sometimes present. And so this is a really helpful guide for us. We use this all the time. It was already stated that cyanotoxins can impact humans through, different routes of exposure, and then also affecting these different systems. Microcystin is a liver toxin, so there is definitely information out there about the impacts to human liver, and I believe that and to human body, I believe that even affects the reproductive system through like decreased sperm count, I believe, and tumors and things like that, and through contact. And we're going to talk about it later one anyway, but something that we were concerned about. And this will be, here's some of the signage that gets put out that we recommend to the public health officer when we see higher toxin levels, either above the, at caution, warning, or this danger one. So it's very standardized, and then people get standard information and know what to, and it's in, English and Spanish, and they know what to avoid. Just give people the information, and maybe they'll still go in there, maybe they won't, but at least they've been informed. So in our monitoring, we track it in a way. We do submit the data to the Water Quality Exchange because it's primarily funded by US EPA Clean Water Act 106 grant. We also put it in a different type of chart so that we can communicate it to local government and also get it into our website. So what you see here are just the summer sampling events of last year, and all of the sites that we measure and we monitor are going down on the left column, and these are the dates up here. So you can see like this place APO1, which is Austin Park, had 100% of the time at caution, warning, or danger. That's what that's showing, and almost half the time in danger, or actually half the time in danger. And, each site has its own characteristics. It's a big lake, and some of them, County Park, that's right down from Big Valley, had caution twice, and below caution, maybe even non-detect all the rest of the times. So this is based on the actual lab analysis, and we create this table so that we can be tracking the what it's looking like around the lake and communicate it to the public and also to local government. Here's 2025. You can see a big difference. Same sites, same length of time. Only a couple locations had danger. a couple of times. So we didn't have any, we had one place that was up to 50% of the time being at caution, warning, or danger, and it was only caution. And nothing more than that. If this one, there's a bunch of them that are 100%, 75% of the time. So that's pretty amazing to have a change like this year. We also have been doing benthic cyanobacteria testing in the local creeks. How am I doing on time?
You're good.
Okay. Oops.
Yeah.
Sorry, I have a
Good.
big thing there. Okay. Apologize. So this map is showing so we're doing grab samples, which is basically you put these spat bags out. We make them in-house, but you can also buy them, and it's a media that we um uh, um we take a certain type of cloth and we soak it with this media that then goes into like a linen bag, and then we attach it to a T-post and pound it into a creek, and it has to stay underwater. So it really needs to be a flowing creek where there's water. And then you pick it up after a week or so, or 2 weeks, depending on your protocol, and send it to the lab. And we send it to the same lab that we send our water samples to. So we decided we wanted to look at, because it's capturing all of the cyanotoxins, it'll capture any dissolved cyanotoxins that are flowing by. We also wanted to do a grab sample, like right then and there. What was the water quality right then and there for toxins, and what is that spat bag been collecting over time, over the week that it's been in there. So the push pins are where we did grab samples. The arrows are where we did the spat bags. And whenever it's yellow, that's where there were cyanotoxin detects. So this is like within the whole county, and we're getting funding from like various sources. So it's not like a full-fledged program, but we knew we wanted to see what kind of toxins were out there. We need to improve our outreach, and be able to depict this with all the different toxins. It's just a time constraints. But we do know that there are all four toxins, main toxins, including the neurotoxins in multiple locations in the creeks. And so when there's dogs in there or people or kids playing or whatever, it's an issue because it could be consuming these toxins by splashing the water or drinking the water, such as what dogs do, or other animals. So when you see animal deaths near creeks, that there's no visual, like there's no bullet or BB or something, or some other, it looks like another animal killed it. It could potentially be a cyanotoxin issue if they drank the water and there's toxins in there, and you're not going to see a green scum because it's benthic. It's going to be down on the bottom, and it looks like there's mushrooms, black mushrooms on the bottom, as they're saying, microcoleus and other. So it's something that should be reported to like Fish and Wildlife and respond to it. So we wanted to get a sense of what was happening toxin wise. We also collect a bunch of other data. It's probably going to be hard to see, but just this is information that uh, standardized with what I believe with what the swamp protocol collects. So we wanted to see if are we seeing any, or collect information about, are we seeing any floating mats? What's the cover of benthic cyanobacteria that we're seeing there? And then just some of our data of what we were noticing with microcystin and saxitoxin and the different toxins. We also do microscopy on those samples as well, to see. And so in this case, we're seeing Gittleronema and Nostoc. So those are, it's just baseline information and useful to see when we repeat the sample, go out again in a week and take another sample, kind of what we're seeing. So really just beginning that program is just a few years into it, and we'll continue to engage on that one. With cyanotoxins in drinking water, we actually had a study going on, as I mentioned a little bit earlier, and the end result was in 2021, the toxin level, we are finding toxin levels in people's tap water, and these are people who have their own pipes into Clear Lake. So we are doing the ambient water cyanobacteria monitoring, so going around the lake to all the shoreline places. But we also had this looking at the tap water of people who had their own intakes, like I said, and finding that there were very high levels of cyanotoxins and intact cyanobacteria even after their or treatments process that they have in their own home. So this is just a snapshot of a press release that we did with the County of Lake on telling people not to drink the water from Clear Lake if they are in pull water from the lake in these certain areas. So that was in 2021. Here's some pictures. These people who look at cyanobacteria are going to be shocked, as we were, that this came out of their tap after their chlorination, after their RO systems, after their carbon media. And so we have something published on this in AWWA, American Water Works Association, but it was quite surprising. We have since continued to monitor people's tap water and for cyanotoxins and other things. And it's useful to see that water quality impacts uses. So we want the lake and we want the tributaries to be cleaned up so that you can have all these different uses, including tribal cultural uses, and not be potentially harmed by them. This is the link for the AWWA where it was like perfect timing in a bad sort of way that it was the same year that the Drinking Water Division of the State Water Resources Control Board required the drinking water systems to the public water systems to test their their intake and their finished water for toxins. And at the same year, we were doing these private system cyanotoxins. So you can see that that in the ambient water, we're finding well, in this particular picture, we're showing that if there's higher levels of toxins in the lake, we're seeing higher levels of toxins in people's drinking water, and these are where these areas around here are where people have their own intakes into Clear Lake. So there's a link for that study. We've also done a lot of outreach with the local community about cyanobacteria and cyanotoxins and asked people about their health issues. And this right here is just a fact sheet through the CalWatch program that we were doing with Tracking California. We got a lot of people surveyed over this one period of time. And through the CDC grant, and found that many people said they were aware of cyanobacteria and cyanotoxins, and that 44% said they had experienced a health issue potentially related, 37% that their animals potentially had experienced symptoms potentially related to HABs. So it's really important to be getting that bigger picture of how is this impacting the larger community, because really for years it was kind of suppressed by by local government because they were concerned about tourism. And so we're like, we're going to go in there and we're going to figure this out. And here's the signage that you can see where there's the QR code and all of the logos, ELAM's logo and Big Valley's and the two cities in the county. And really kind of honest conversation that, you, that could produce toxins and just, to be advised about things. So that was a huge win. Here's a little bit about the water quality conditions. I mentioned, well, we have a Facebook page, Clear Lake Water Quality. So we'll put information. This is an older one, but I wanted to show there's a lot of engagements that we get on this because really people just want to know, and they know we're a good source of information. We're just taking it from the lab results and posting it. So that's what we're doing with it. And also Big Valley's Facebook page. We also use the information with fish kills. So even though fish kills are, can happen for a lot of different reasons, as it was discussed earlier, that cyanobacteria, when it starts to die off, it will drop the oxygen level. Just any sort of organic matter that dies off in water drops the dissolved oxygen levels. And fish need a certain oxygen level, 5 parts per million in cold water and 7 parts per million in warmer water, I believe, shouldn't go below. So we started a fish kill monitoring project back a few years ago, can't remember when, 2021 maybe, and asked people whenever they saw dead fish of, a bunch of them to track it. Well, in 2020, and looking at it over the years, because we created a database for it, that it is the summer months when there's the most fish kill. And this is really underreported, but these are the number of fish that people were saying that they saw, like adding it all up through not only our iNaturalist page that you saw there, but also just the reports in media. So in 2025, there was a big fish kill. It was kind of lake-wide. We started to map where these things were happening. Um, People were noting it. Here's like a piece of our spreadsheet where people are saying which fish it was. So we were just noting all that when they were seeing it. And what they were saying in terms of numbers of people are like millions, so write that down. And as we're out there and looking at that, we are also watching our data logger. So we've got a couple of data loggers that just take continuous readings, and these are some of the readings. When cyanobacteria is dying off, you're going to see that dissolved oxygen drop, and so that's the purple. And it needs to really be in this level here, between 5 and 7.5, and we're seeing it drop well below that for a number of days in a row. It might be just because the water temperature is so warm. I mean, matter of fact, the water temperature is on here, and the water temperature is dropping too. So, and the dissolved oxygen is dropping. I wish I had phycocyanin on here to see what the cyanobacteria is doing. Um, but I don't. And but we know that when there's a big bloom, there's a lot of oxygen for a while, but then when when it starts to die off, it really drops. So kind of putting it all together, this whole carpet right here is a fish kill. All these fish, lots of dead fish everywhere. We asked people just to report, in our Clear Lake Water Quality Facebook page. So just for documentation. So this all relates to our cyanotoxin cyanobacteria program because, we're also out there looking at what cyanobacteria is there. Here's a table of what was present, at each location and each date. And I showed this because you're seeing this word Seneca cystis. We are seeing Seneca cystis as a dominant genus for weeks and weeks and weeks. And this is why I think we didn't have high toxins last year, because I think even though it's a microcystin producer, it really wasn't producing much microcystin. And this is what it looks like under the microscope, are these like pairs of cyanobacteria. And this is what it looked like, the Seneca cystis dominant bloom in 3 different locations. So it's green tinty, but this looks more green, but it's more of a green tint. This is right before the fish kill, and there was a fish kill in these areas, and this is right after the fish kill. So you can see, that there's less cyanobacteria in the water, and so there probably was a Seneca cystis die-off happening, but again, not much, really not a big bloom like you'd normally think about it. But it does have it could have an impact if the cyanobacteria is dying off because it drops the oxygen levels. And we're seeing that not only in the data logger data that I was showing you there, but also Robinson Rancheria was out there taking vertical profile samples and seeing low dissolved oxygen at the surface, the middle, and all the way to the bottom of the lake. And so it's just a big drop off of oxygen levels, and a cyanobacteria bloom going on that isn't the one that we normally see, but it was also dying off. You could see this is something we use a lot at that time. There was not a high level of phycocyanin, which is the pigment produced by cyanobacteria, but you could see that it is lake-wide, and that it was present at that time. This is my last few slides, just moving into another thing that we do with cyanotoxins in fish is that we want to see if it's in the fish tissue. Had a little slide about it earlier. We had a Cal EPA EJ grant back in 2018, and we had a number of fish that we had collected over the years and had stored and inventoried when the fish came in. And so we could see that we wanted to look at it from a seasonal time, location, and also species specific, which just what the toxin levels are looking like, so that we could recommend fish to avoid. Usually, this happens with methylmercury. You'll see OEHA has the fish consumption guidelines for methylmercury, and they're not really doing that for cyanotoxins because cyanotoxins don't stay in the tissue for very long, from what I understand. They don't like build up and sort of that each successive fish higher up in the food chain is going to, basically accumulate whatever it ate plus whatever more. So that's supposedly not happening with cyanotoxins in fish. However, it is in fish, and it is something that tribal members are eating and Native people and others are eating. And so I still think it deserves some sort of warnings or something. And so we're working on that. But here's the study we did in 2018, and then here's our second study that we just finished last year. Again, looking at multiple species. The levels are much lower now. So the highest cyanotoxin level in fish tissue was a Sacramento blackfish, which is not a fish that we see very often in the lake, but it is a native fish. So we had 79 fish samples from 10 different species from 2017 to 2023. 65% had detective microcystin in them. And yeah, just the toxin levels were definitely lower than the previous cohort of study that we did. But again, we're planning on doing another one of these. We're interested in how cyanotoxins are impacting the food and medicines of the tribe as well as the water, because we have precious people to protect, and we want the data, and we want to adapt and change the policies of water management so that it could be safe to do things traditionally like the tribes have always done. And I think that's it. Thank you.
Wow, that was amazing. I've seen you give, different versions of that presentation for years. And every time I'm just like blown away with the breadth and depth of your program that you've maintained for many years. Yeah, so I'm just trying to catch my breath, but I can't imagine how you're doing. Any questions, thoughts for Sarah? That was a lot to take in.
And we're always happy to answer questions for folks so they can send an email. There's a lot of things that people could do just to get a program started, which won't take very much. And we've only kind of moved into all these areas because we've had all of these blooms here. And we've helped other tribes with their sampling. We've had them ship us their water samples. We've looked at it under the microscope and even sent off for analysis. So we're happy to help with things like this. But as you guys have mentioned, the state also has some programs that they could help. And I think it's important to get a baseline. But yeah, thank you, and happy to answer questions if there are any.
And like I said, if you want us to pause the recording before you ask your question, we can totally do that. You stunned us all into silence, Sarah. You mentioned a little bit. Oh, Marissa, go for it.
Yeah, just because it's silent right now. This pause. Wanted to say thank you so much, Sarah, for this presentation. Really great to show like how monitoring can change year to year depending on the capacity, the resources, the interests too, right? And also seeing how HABs really can impact so many different uses. So sometimes you'll want to look at the fish or this particular type of fish or this area of the lake. And this is showing how like it starts it's like bringing together like the whole picture of what's happening in that aquatic ecosystem and like what could be happening, like this impacts to the community. These examples are just so critical to share. And this is inspiring. Thank you again, Sarah.
Yeah, I think one of the things that's been really fun is the microscopy part of it. And again, we don't have anyone on staff who went to school specifically for that, but there are these classes that are offered from time to time that we always keep an eye out for. Greenwater Labs in Florida they're what's his name? He's amazing. Has come out and done classes before, regionally. And so we always try to go to those so we can just keep our microscopy skills up. But in doing that, we've found that there are the nitrogen fixing cyanobacteria really kind of take over first and pull nitrogen into the water, and then there are different genera of cyanobacteria who take over after that and become dominant. So it's really interesting to see the cycling of what's growing in the water. And if you start getting involved in solutions, like having that type of knowledge is really helpful because you could see that the water chemistry change and just the species or the genera that are there change. So that's been a really fun part of this. As a matter of fact, for my birthday one year, the staff gave me a microscopy photo, so it's on my desk over here. It's just some really beautiful cyanobacteria, so it's just nice.
I love that.
Yeah.
And I just also wanted to point out, you mentioned a couple of different like funding sources throughout your presentation for different efforts. We have some listed on a follow-up slide too, but just to note that like it's what I'm hearing is you can kind of like start small with certain pieces and build up your capacity, get that microscope and like figure out the baseline of what's happening without too high a cost, and then adjust accordingly as programs build and you have more capacity and funding resources and things like that. Okay, any questions for Sarah? Feel free to, I don't see anything in the chat. Feel free to unmute. Okay. No worries. Sarah, can we get a copy of your slides so that we can share them with? Great. So Sarah's contact information will be there. If you want to reach out directly, there's also reaching out to the CC HAB network if you're trying to get started. Like that's a great resource as well. I was almost gonna keep going on the presentation, but you all can't see it, so I need to share my screen first. Yeah, thanks again, Sarah, so much for kicking us off and really showing the amount of work that you've been doing, you and your teams have been doing for a long time in partnership with other tribes and things like that. It's just really impressive to see and to learn about. I learn from you every time I talk to you, of course. But to do all that, we need resources. we need materials, we need people, funding. And so before we close today, we're going to end early. It looks like I just wanted to point out some resources that are available to you all now. If you want to dive deeper into certain things, the first is the CC HAB Network HABs portal. So there's, we saw graphics and data earlier when Marissa was talking about our HAB reports map. So if you are curious about where people are reporting HABs near you, you can check out this map. It updates daily. Is that right? With
That's
incident
right, daily.
reports. Thanks. With incident reports, so you can see like what other people are seeing. If you want like guidance on what the signs that you might see near a water body mean, we have posting guidance and more details about the different advisory signs. We're also going to talk about that in much more detail. Sarah mentioned different thresholds when she was going through her presentation, so we'll dive deeper into that at a future training. When there's a HAB, practices on how to stay safe, how to utilize that water body in a way that's safe to protect the health of yourself and your loved ones and your pets and things like that. And then if you're interested in monitoring yourself or building out your program, growing your program, we've got a ton of guidance and resources free and available online. So when Carly was presenting, we had a link to that ID guide, but there's lots more about like detailed sampling guidance. Again, we'll go over a lot of that verbally together at a future training, but if you just like can't wait until then, this website is ready for you. Sarah mentioned the HAB satellite map. And there's a link to the map here, and it displays imagery for many water bodies in California. We don't issue advisories based on the satellite imagery, but it can be a great way to like get a baseline understanding of what might be happening. And it includes a lot of different information and can be used to inform your monitoring and assessment. And again, we'll do in a future training, we'll dive deeper into this resource and maybe do a little bit of a demo. But before I go on to the next thing, Carly, Marissa, are there any other like points about the satellite map that I totally skimmed over that you're like, no, they need to know this now?
Yeah, thanks for bringing that up. Yeah, so satellite imagery is so useful. It's really great tool that we even can have, and we can be able to detect from the satellite imagery cyanobacteria at the surface of the water. So based off of those pigments, Sarah mentioned, looking at chlorophyll and phycocyanin several times. Those are pigments that are in the cells of cyanobacteria, and we can detect them from the satellite. And we can also look at chlorophyll separately. And so you can see also if you got a major algae bloom, again, that green algae, you can detect also the chlorophyll in like aquatic plants. If that's really taken over a large area, you can see that there as well. And though it doesn't tell you like the toxicity, it does tell you that it's there, and it's something to go, in person, down on the ground and verify and determine what the toxicity is. And you can, especially with large waterways, know which side to go, right? Because it's hard to access things if you don't have a boat to go like the east or western side. Most of the time we see them like where the wind goes. A wind brings the current. Sometimes just lake wide, like this imagery is showing you. But yeah, we'll have more on this and how to use the tool soon. But feel
Thanks,
free to
Marissa.
ask us for any demo. We can do that over the web with you.
Yeah, awesome. I mentioned our website has a bunch of monitoring resources. This is just a list of the types of things that we have ready to go for you. So they're, Sarah mentioned, sampling checklists and things like that, and their in-person tribal training. We've got some sampling checklists, supply lists, guides and instructions on like how to collect your samples, training videos, things like that. Again, we'll go through all of these resources in more detail, but Carly added to the chat, feel free to reach out to us directly through the HAB Reports email, and that'll be on a future slide as well. If you're thinking about wanting to start a program, grow your program, and you just want some like consultation, not formal tribal consultation, but some, you can always request that, but some assistance on getting things started and some guidance from our perspective, we would love to be able to support that if that's of interest to you. This is a bunch of links to national resources that you might be interested in. The National Office of Harmful Algal Blooms, US EPA has a cyano symposium that they have every other year. We have, they're having one this year, and there's a slide on that next. But there's a lot of great resources from like the federal level that exist. But like I said, we all need money to do this, to pay our staff, collect the samples, send them for analysis. So here's a list of a number of resources, potential funding programs that tribes might be interested in opting into, applying for, shout out to the water board's funding opportunities, the Cali PA EJ Action grants, and there's also tribal specific funding for things like this. And there might also be funding through the California Water Board's SAFER program, so safe and affordable drinking water. So Sarah mentioned there's a direct link with drinking water and HAB. So if that's something that you want to investigate, that might be another funding source to look into. This is just a save the date for the National HAB Cyano Symposium. It's virtual. And it'll be in March. There's links to the program, a link to the past symposia and webinars, so that 2023 Science Symposium. Carly, Marissa, do you have anything else that you want to share about this?
Yeah, I'll go for it. It's free, so that's great.
Hey, that's good.
And yeah, it's held virtually every year, and it's usually this year it's gonna be focused on like health, especially dog health and different things, but they usually get a really good breadth of knowledge base from like all across the country. So it's just a great platform to learn from what other folks are doing. And then also it's just a great way to advocate with USCPA for your interests as well for future symposiums. But they've been really fruitful and really a lot of great information. So recommend it.
Nice. Thanks. And just flagging that the time 1 to 5 is Eastern. So if you're on the Pacific, it'll be a different time, but half day, which is great. Okay, wrapping things up. I am gonna try and get the slides and the recording and everything sent out to you directly next week and posted online around that same time. So if you registered for this training, but you're not live with us, you'll still get a direct email from me, Anna Holder, with links to the slides and the recording. There's also links for the next 2 trainings, where in February we'll talk about response, how the SWAMP program responds to bloom reports and how we work with our partners to do that. And then in March, we'll really take a deep dive into the public health coordination and communication. So we'll talk with the illness work group members. We'll dive deep onto like what the thresholds are and how that triggers, caution, warning, danger signage, that sort of thing. And we've got other trainings in the works. So we're hoping in April to go like that deep dive into monitoring design and an introduction to data quality and management. So, before you're even thinking about going out in the field and sampling, what are the things that we think about as a program to get ourselves ready for that? And how do we get our data systems ready to handle the data once it comes in from the field or the lab? In May, we'll do a deep dive into sample collection. So that's going to be super great. We'll talk about the different types of sampling that folks can do, different resources that are available. And then we're going to take a break because we anticipate HABs to be happening. You all are interested in HABs. You're probably HAB practitioners yourself, so you might be in the field this summer. So we're going to take a break. And then towards the end of the year, we'll figure out specific dates later and actually send out a poll to you all in July to figure out preferences potentially. We'll talk about data analysis and interpretation. So you get the data back from the lab or from the field. What do you do with that? How do we from the SWAMP program interpret it? What are our recommendations? And then at the end of the year, we're probably going to have a lot of guest speakers that are focused on mitigation, research, and case studies in the harmful algal bloom space. And just like we had Sarah today give a great presentation from the tribal perspective, tribal environmental department program perspective, we're inviting tribal practitioners to all of these other courses too. So you don't just have to hear from Marissa, Curley, and I. You'll get to hear from your tribal colleagues. Links to all the things, registration, slides, recordings, anything like that will be on the training series webpage, which is on the bottom of the slide. And we'll also send out announcements to the CCHAB network email list and to the Water Board's Tribal Matters email list. So if you are on one or both of those, you'll be hearing from us. Hopefully it's great. That's all we have for today. We're ending a little bit early. I don't think anyone's mad about that. If you have questions about anything you heard today, want to follow up to dive deeper into your monitoring programs and what resources we might have available to support your work, feel free to reach out to myself or the CyanoHAB reports email directly, and we'll get you to the right people. That's it, folks. Thanks so much for hanging in. I know it's a lot of information in a short period of time, and your time is very valuable. So we really appreciate you joining us live or watching the recording. And we hope to see you next time. And I'll just note, yeah. Great. Bye, everyone. Have a good afternoon.
Bye. Thank you.